we are live. Hello, everyone. My name is Eduardo Rabelo. I'm a solutions architect based in Auckland, New Zealand, and this is the second episode of From the Field. From the Field is a show hosted by the New Zealand technical team, where we will talk about tips and tricks, solutions, and some lessons learned from the field here in New Zealand. And today we have a super special guest, the man behind helping startups across New Zealand, from IoT to machine learning, the legend itself, Stephen Martin. How are you doing, mate?
Hello, well, thank you. Tēnā koutou katoa.
Fantastic, lovely. Look, for the people that don't know you, can you introduce yourself and tell what you're doing right now at AWS?
Sure, yeah. So I moved to New Zealand about 8 years ago. I came here working for Palantir back in the day. Then I was at a startup called Marcelo here in Wellington, where I live, and then joined AWS about 2 years ago now. So I spent my first 12 months working with Zero as their solutions architect, and then coming up on a year ago, I moved over to startups. And so in my role as the startups solutions architect for New Zealand, I work with the business development folks and sales folks to support all the startups, big and small, across New Zealand, which in many cases means kind of trying to discover where innovation is happening, whether it be in an accelerator or an incubator or universities or whatever, and then go to those people that show promise and help them kind of benefit from cloud economics and get ready to scale and enter global markets. So there's lots of super cool startups in New Zealand right now, and I think we're poised for a very interesting next 4 or 5 years.
Fantastic! What a journey! That's pretty cool to hear. So I see we have a talk here around computer vision and AWS at the edge. But before we start, a few days ago I saw you on TV. What was that about?
I'm pretty much famous at this point. So we went to I guess my specialization would be edge computer vision and kind of machine learning and agricultural technology. So I'm a member of the global ag tech field specialist community for AWS. And so one of the things that I was really lucky to be able to be involved with was going down to field days or up to field days in Hamilton and doing some presentations on computer vision and kind of why it's relevant and important for the future of agriculture and primary industry in New Zealand. Someone important and talented dropped out, and so they plugged me, and it was really fun sitting down with Tay Radar and some other very properly smart and talented folks from Halter and LIC that are doing some really cool stuff in agricultural technology. And it was really fun. I got some mud on my gumboots, and I got to see a proper piece of Kiwi culture, which was really cool. Sometimes I feel like I don't get out of Wellington enough, so it was good to get up there and meet some people.
Yeah, to be in the field, right? That's excellent to hear. So it's fair to say that computer vision is a trend on agri-tech in New Zealand?
Yes, I do think it's fair to say that um, some of our most exciting startups are really leveraging computer vision in different ways. So one startup called, for example, Hector, is using computer vision that's based on a cell phone, typically, to take pictures of apple barrels, and then to kind of grade apples based on that cell phone imagery that goes to the cloud and then does some computer vision magic. Another one named called Cropsy is another one of our really cool startups that's doing viticultural assessment using computer vision on the edge. And they were actually the winners of a couple of awards at Field Days, which is great to see. And then there's, of course, the tie-in with kind of robotics for things like pruning, weeding, and picking, especially given the lack of seasonal workers who are able to enter the country during COVID to come and help us with our primary industries. That type of ag tech that's right at the intersection between robotics and computer vision is really taking off and becoming a lot more economical as hardware prices go down and the accessibility of computer vision and machine learning increase. Yeah.
Oh, fantastic. And that means we will learn more about this magic today. So the stage yours, my friend, and let's do it.
Okie dokie. Cool. Um, right. So we're going to talk a little bit about AWS at Edge and specifically computer vision. So um, the first thing I wanted to do is unpack a little bit about the third word on that slide, which is the word edge. So it occurred to me. So I was running around the house, giddy over the work I was doing with computer vision, talking to my wife, and I kept being like, edge this, edge that, and like, we've got these, like this little guy, we've got these little devices, and we can deploy models and machine learning to the edge, and it's so exciting, blah blah blah. And after about 6 months of that, my wife finally stopped me and said, "I just want to clarify. When you say edge, do you mean like the browser, or do you mean like the edge of like the like the edge of the computer?" And I was just
Where's
like,
the edge?
"Oh, yeah. Where is the edge?" Okay, cool, fair enough. And then I kind of started looking back through some of the documentation, and the word edge is like way overloaded. So I just wanted to kind of define some, going from big to small, some trends that I've seen in edge, and really define with a bit more precision what I mean when I say edge, as opposed to other types of edge. Q. So here we have a beautiful network, and this is kind of, from my perspective, we were living through an interesting time in terms of the development of network topologies over the last several years. So when networks kind of first started, when they first started, it was point to point. But enter cloud, enter AWS and data centers, and you have there was a big trend toward a contraction of the network, or a hierarchical organization of a network toward a central node, and then spokes off of that hub. And so that is the basis for what we call in AWS cloud economics. So economies of scale generated through specialization at the center, which lets you amortize the costs of things like um, uh, infrastructure and network security, automation, scaling behavior. That's how we can offer things like spot pricing and Fargate spot, and savings plans and reserved instance, and all this flexibility around how you use compute at the center. And so for a long time, that was where the efficiencies were to be gained, was by this kind of almost enthalpic, to use a physics
Yeah,
term, like
it's what
contraction.
we call the economics of scale, right? Because of the
Yep,
size that we have.
exactly. Yep. And so we rode that trend for a long time, and it was great. And then in somewhat more recent times, we've seen a little bit of a change in that behavior. So rather than this monolithic move toward the center, we've started to see more differentiation in terms of the center of the network. So rather than just having regions, data centers, availability zones within a region, we started to have different types of kind of nodal infrastructure. So for example, now we have local zones in AWS, which are kind of another flavor that's smaller than a region or an availability zone, has a different mix of services, but it's also still kind of it consists of devices and hardware, so it's on the spectrum of edgeness, I call it. So like if you think about a data center or an availability zone on the one end of the spectrum of edgeness, not very edgy, versus like one of these little microprocessors or a Jetson Nano, which I'll be running today for the demo, like that's well over on the edge, or on the spectrum of edginess. And so we saw this differentiation and moved toward a decentralized network architecture for cloud, which was cool. And then building upon that, kind of where we're going now is into a distributed architecture, a networked architecture. So rather than there being this very clear distinction between the center and the edge, it starts to be real shades of gray, and that edge moves even farther along that spectrum toward devices that are physically co-located within close kind of network proximity to the workload being served. So yeah, and so that's kind of where we are now. That there's efficiencies to be gained by through both the economy of scale of moving things to the center, but also in terms of moving a piece of tailored hardware to a place that's physically adjacent or a network adjacent to the workload being served. So that's when I say the spectrum of edginess and other ridiculous terms like that. That's kind of what I mean. And we're going to be way over on the edge of the spectrum of edginess toward small devices that are directly connected to the workload being served.
Fantastic.
Yeah. And so and something else. So I give this presentation here and there, and I sometimes like to I have some icons up there, and those in my brain box represent kind of different technologies that have allowed us to go on this journey toward a distributed network topology. So I sometimes quiz people, but like actually, let's do it. Let's do it, Eduardo. Do you know?
Right.
What's so Docker is pretty obvious. I'll give you that one. Docker.
The name is there, right? There you go.
So that's kind of containerization, which is to say abstraction of pieces of code and infrastructure that can be deployed onto different types of infra. So that one's a gimme. Do you know the other ones?
Well, let's see. I think on the top left we would have what looks like a instance, maybe. Yeah.
Yeah. So
a compute. Some
EC2.
kind of compute. Yeah. Right.
EC2, yeah, which was foundational. Like when EC2 came along, and you could, create these boxes and spin them up and spin them down of different sizes and different profiles. Like that was amazing. All right, yeah. What else?
Back in the day. Let's see. If we go clockwise now, we have the green one here on the bottom right. I can't remember that icon, to be fair, but I will guess something related to maybe code pipeline or something.
Good guess. That is CloudFormation.
CloudFormation. Yep. It's almost there.
It's very close.
Something related. There we go.
Very
Pretty
close.
good. Yep. We have some comments on the chat. People saying EC2 scaling is the last one. Maybe. It looks like a multiple instance, multiple computes over there. There we go.
Yep. Yeah. So CloudFormation is kind of like, I use that icon because like we're on, we're in the AWS Twitch channel, but like that one's kind of just like infrastructure as code. So like when you start to get into using Terraform or CloudFormation,
even CDK nowadays, yeah.
Exactly, CDK. It's a way of automating your infrastructure, and that gives you like a lot more scale by taking, getting people out of these manual processes and allowing you to spin up infrastructure in different regions and to do it with an even smaller team, less hands on keyboards. And then the last one there is, do you know that last one?
Let's see if someone in the chat know that. Last one, people. Bottom left, the yellow one. Anyone?
It's okay. It's not very frequently used.
Okay, some hints over there. There we go. Someone? We have one ECS.
It's Lambda. It's Lambda actually. Ooh. So yeah, it's usually when you think of Lambda, you think the actual Lambda symbol with the circle around it. But
you're tricking us here.
Yeah, it's very tricky. It's very tricky. And that one's kind of like, it's a bit of an evolution of the EC2, like boxes on demand, compute on demand. So like Lambda was an interesting extension of that into serverless, which unlocks all these other super interesting opportunities to change our topology of the network. So yeah.
Fantastic. So from EC2 instance to Lambda and compute on the edge. Let's see.
Yep. Sweet. Right. So we're going to talk a little bit about. So I talked about cloud and the centralization of resources, and then edge, right? And so somebody might say, well, which one's better, right? Like if I was talking to a customer, they might say, all right, well, so I've got edge, I've got cloud. It used to be that everything was edge, right? Because it was like everything was on prem, or it was on my box under my desk. And so now we've moved to cloud. We just got done kind of moving to cloud, and so now you're telling me we need to move back to edge? Like, come on, man. So this is kind of, I wanted to talk a little bit about like, when is edge good, when is cloud good, and in reality, you're not going to use one or the other. Like it's going to be a blend and a hybrid of cloud and edge, and the trick is getting that blend and the shape of those tumblers right, so that you're gaining the best of both worlds here. So starting with cloud, I kind of already talked about it, but like you have centralized economies of scale. You don't have to maintain any hardware. You can do things like scale up and down very quickly for compute intensive workloads like machine learning training. And it's super easy to manage because the undifferentiated heavy lifting of management and automation is kind of handled to increasing levels by managed services that basically increase the level of abstraction for the management over time.
And
So
we are launching new ones pretty much every year, right? Yeah, so absolutely.
absolutely, yeah, and it's super interesting to watch as a solutions architect because like it's basically like, it used to be like pretty low in terms of the abstraction. It was a low level abstraction of like, okay, we've abstracted you know compute or like a server. Okay, now we're going to abstract away the orchestration of servers. Now we're going to abstract away the orchestration of the orchestration of like
Sorry.
it's just moving higher and higher and higher so that the developer can focus more and more on the things that make humans really interesting and unique and creative, and less on the rote tasks that machines are good at and I am not. So that's cool. However, on the edge, you also got some pros. And so those are things like distributed localization. So you can have theoretically a piece of hardware that is specifically designed and adapted for the workload that it's supporting, which is great. You also, if you buy a piece of hardware, so uh, yeah, this thing, I don't know if my cord's long enough. I'll show you later. So I have like
All
my
right.
Jetson down here, and it was like Jetson Nano. It's got a GPU and a big heat sink on it, and a bunch of goodies and connectors. Like I think that's like I think $50 US
Wow. And
for
it
sale in the
ships to New
states.
Zealand?
We've managed to buy here. I'm not sure if you can
Oh,
buy them at
cool.
that price in New Zealand, but the prices are just coming down all the time, and the power is going up. So, like, if you wanted to cough up a little bit of cash, like you can actually obviate the need for an ongoing spend on compute in some use cases. And then, of course, edge compute, like probably the biggest thing that people think of is that it's very low latency. So that's the reason why we use edge compute on things like self-driving cars and autonomous vehicles, because like latency cannot happen. If the car is rolling down the street and then here comes the beautiful Dalmatian and it looks meekly at the car and the car is like, oh, is that a Dalmatian or a speed bump? Like it has to be able to make that determination very quickly. That's very important. So latency is important. And then of course, in many cases, certainly in New Zealand, but pretty much everywhere I've worked, although it's been a while, like you never have enough bandwidth. And just like um, that compute is improving, um, so are cameras. So like
Hmm.
in lots of places in New Zealand, especially in agricultural reasons and places where we're doing primary industry, you're just not going to be pushing 4K 60 frames per second
Per second, yeah.
video um, across a 4G network with multiple. It's just not going to happen. Or if it does, like you're going to be paying a lot of money and you're kind of brute forcing it. So reducing by orders of magnitude the amount of bandwidth that you need to do inference and machine learning is the other big pro. So yeah.
And the difference here, we also circle back on that blend and gray area that you mentioned. That is a mix of both, right? You do the compute and the processing in the edge, and you store that in the cloud on your own environment. So then you can do post processing from that and analyze that, and have more machine learning on top of that to learn from your IoT devices on the edge.
Yep. Yeah, that's right. Yeah. So in the demo that I'll be showing, like you you capture so you capture video with like a cell phone. So you capture an MP4, you stream up frames to the cloud. You used SageMaker, which is really, really good for high scale training and compiling models and this really grunty stuff that requires a lot of power. Like I don't want to have, a bunch of GPUs heating up my room. I just want to ship that out to the cloud and then receive the product. It's not super latency sensitive. And then once all that grind is done, then I take this beautiful compiled, trained, optimized model and I pull it back down. It's about 40 megs back onto my little device, and then I get it going and get it doing inference really, really quickly. So it's about that journey of the data from edge to center and then back again.
Is what you say. It is not one against another. Is both working together.
Totally. Yeah, yeah, yeah. And if you can get that mix right, like it's cost effective and it's super performant. So yeah. Oh, yep, cool. Right. So there's the edge in the spectrum. So there are lots of different. So again, there's heaps of different types of edge in AWS land. I'll just talk about some of those types of edge. So here you've got so AWS Storage Gateway, and this is kind of the type of edge that is it's kind of like an on-prem. So you have an on-premise situation where you have boxes that servers that you manage, and those servers need to communicate with the cloud, maybe for backups or whatever. Like that's kind of an edge type use case for one thing being on-prem communication with the cloud or a hybrid cloud. Another one is the Snowball family, or the Snow family. So that's all about like they used to say, and it's still true, which is crazy. But like, what's the fastest way to move a petabyte of data from New York to California? And it's like a truck full of hard drives going 80 miles an hour. That's still the case.
Still
So
sustain, yeah.
yeah. And now there are heaps of different like types of Snow appliances, which are really cool for getting data into the cloud generally.
Including a truck.
Including the snowmobile, yeah, the truck. It's pretty cool. Then you have things like so non-traditional types of infrastructure. So like we have AWS local zones, which hang off of availability zones, but also wavelength, CloudFront, which is the AWS CDN, and even outposts, which are these big AWS servers that can be racked into a data center, but they act like AWS services, but they are physically located within another data center. Have you ever used any or done any outpost stuff, Eduardo?
Not yet. I heard some stories here across New Zealand, but yeah, I'm still waiting for my chance to work with that.
Yeah, it's pretty cool. It's pretty cool, like that blending that kind of black line between what used to be data center and clients. Like there's a lot more gray area in there, and it's a lot more rich, which is cool.
And kind of a peek behind the curtain, right? Because everyone thinks the cloud is something magical, but it's not. It's something physical, similar to a rack like that, but on a complete immense size. So yeah.
Yep. Yeah. Oh, yep. And then the last stuff here, I think it's the last stuff, is kind of the IoT family. So this is kind of another flavor of edge, right? Like you have, excuse me, like microprocessors or devices that are temperature sensors. I have some scattered around here, or IP cameras, or whatever. Those are all very, very small devices that are generally running not very low power in terms of compute or power consumption. And so, in the very near future, there are going to be many, many, many of these things. And so managing all these devices at scale is kind of another flavor of edge. Cool. Yeah, so digging into that a little bit deeper. So on that last one, so the IoT stuff, we provide so Amazon is a committer to a project called FreeRTOS, which is basically an operating system that can run on these very, very thin, lightweight devices. So this is one way that we kind of support development at the edge. Another one is Outposts, which kind of we already talked about. So it kind of quacks like an AWS service. It looks like an AWS service. It feels like an AWS service, but it is indeed local, which is cool. And then, of course, like I said, the Snow family. And so that's Snow Cone, Snowball Edge, Snowmobile, which is the truck. And then basically all that is a way of moving between customer site, edge, cloud. Yeah. Sweet. And then there's one other one that is kind of related to the work that I do. And is I feel like it's one of Amazon's least appreciated services because it takes you a little bit of time to get your head around it. But like IoT Greengrass, so AWS IoT Greengrass V2 specifically, is a really, really cool way of interacting with the edge. And it's cool because it used to be, for anybody that used to do a little bit of development on like a Raspberry Pi or an Arduino or whatever, like it used to really matter like what device you were working on, and the level of abstraction was quite low. So like doing things like making sure that your hardware could support machine learning inference, or that it could effectively communicate with other stuff that it was plugged into, or that it was secure and its credentials and secrets were being managed appropriately, or that it could run a container in a consistent way, or that it could stream up, like all these different things that we kind of take for granted nowadays were difficult, especially across a wide variety of devices. Um, but like
And not too long
yeah,
ago, that was difficult, right? Because Greengrass 2 was released like last year, I believe. So it was a quite new
it's recent,
release.
yeah,
Yeah.
yeah. And it used to be just like it was just a nightmare dealing with these devices out in the field. But now with Greengrass, you can do things like so you can uh, basically create a device shadow that represents that device, even if it's not connected to the network. You can use an IoT Greengrass core device to do things like rotate your credentials on all of your edge devices, and you can manage. It used to be that managing a fleet of a dozen devices out in the field using SSH and just scripting like is super brittle and painful. Like now you can certainly manage hundreds or thousands or more of devices at scale in a way that um, like doesn't require a super genius dev to manage all that stuff. So Greengrass is kind of another extension of this work at the edge to not only be able to deploy to the edge, but to be able to manage large numbers of devices at the edge doing interesting things.
We do have a comment around on the chat. AWS IoT is a whole new world. So it definitely feels like, right?
Oh yeah. There's a few domains in AWS land that I'm just like, once you lift the covers on that, you better have a year. I shouldn't say a year, but you better have some time on your hands to really get in there and get your hands dirty and appreciate what's going on. And IoT is one of those for sure. It's just a whole, yeah, like I said, a whole another world. SageMaker is another one. Like there's just so much functionality now for doing machine learning. And then of course serverless is another one where it's just like you could swim through that like a fish in the ocean for a long time and be intellectually stimulated, I reckon. Yeah.
And that's why we are learning from the field. And the sessions over here is to clean, at least show you the initial path and see how we learn from our customers and how you can avoid some mistakes during your journey. So there we go.
Yep. Yep. Uh, Cool. So moving along past that, so that was kind of interesting. No, I don't know if it was very interesting, but that was kind of theory stuff, and just kind of like highfalutin.
Now is the
You
fun
know,
part.
yeah. Now getting down to brass tacks, and it turns out that yeah, getting down to brass tacks was challenging, and I'll explain why. So a little tiny bit more. Amazon. So in Amazon, we have this thing that like, so there's a question like, well, what if there's different teams that are building a similar service or a service or a project that solves the same problem, and in AWS we think of it as like, well, 1 + 1 is still 2, and like that's pretty dope. So it's we err on the side of making too many services that solve the same problem in hopes that one will eventually kind of uh, are like rise to the top as the best solution, but we're not afraid of you know lots of different approaches to solving a problem. And so that's certainly obvious with this list. So these are all, well, these are some of the different AWS services that relate to computer vision. And specifically, we're going to be kind of talking about this bottom bit here, which is around edge computer vision. Yeah, and so the thing about these is like they're all super cool, especially well, Neo Deep Learning Runtime is one of my favorites, and SageMaker Neo. But a lot of these ones that are closer to what we're doing in terms of edge computer vision, they actually are quite catered toward industrial use cases or a high number of users, bespoke hardware, um, bigger scale deployments. And
Mhm.
because I work specifically with startups, I want to make uh, experimenting with edge computer vision as easy and as accessible as possible, so that folks can get out there, give it a shot, and see if it's going to be valuable for their business. If not, they only wasted a couple hours, and if so, then they can grip it up and run with it. Yeah.
Fantastic. And just reading this list, I can see where some solutions are really close, or when you would talk about like the cloud and the infrastructure, and what is actually the edge, which is close as a real device. We can see the solutions like from top to bottom. They start like, okay, this is hosted on the cloud, is on AWS, and then when we go down, we can say, okay, these are some physical solutions that I need to have near to my site, and then I work with that with my solutions in the cloud, which is fantastic.
Yeah, man. Once you start thinking about things in terms of the spectrum of edginess, it just it all makes sense.
You
Um,
say it first. There you go.
I remember when I first started studying machine learning, and I started to learn about, like, it was like, all right, so we've got 2 dimensions, right? And it's like 2 dimensions is a plane, and you can imagine, like, you have a bunch of units, 2 dimensions, like pixels or whatever. And then I remember, okay, 3 dimensions. All right, cool. I can picture 3 dimensions. Like, okay, I got another dimension that goes into the z-axis. All right, now let's think about 50 dimensions. And it was like, what? Yeah, that dimension that you just pointed out actually kind of reminds me of the dimension of the spectrum of edginess. Anyway, cool. So yeah, a little bit more like Panorama is a service that's actually quite close to the Evergreen service, but it relies on computer vision appliance, and it's quite the problem it's solving, I think, is grounded most in kind of industrial vision, which is cool.
Mhm.
And yeah, and so the last bit of grounding and orientation here is this is kind of the AWS machine learning stack. This is how we think about it internally. Um, and here we have another dimension. So the dimension of kind of abstraction. So at the top we have our AWS AI services, and so those are typically services that are cloud side, running cloud side, that are accessed via APIs, like everything at Amazon, but APIs that are at a quite a higher level of abstraction. The devs aren't going to be able to really get into the nuts and bolts of the data science or the models that are underpinning those services. They're basically taking those optimized models, and with a degree of flexibility, but they're kind of sacrificing that flexibility for usability in my perspective. Then we go down one layer to the machine learning services. And so these services, this is where I spend most of my time. So these services are more flexible and more complex. So here we have SageMaker, Ground Truth, Marketplace, the SageMaker Studio IDE, which is basically a one-stop shop to run a machine learning practice, which was challenging, as well as Neo for doing things like compiling models for specific hardware architectures, or augmented AI for doing review and yada yada yada. So if you're a technology company that wants to use machine learning as a core part of their value proposition, this is probably where a lot of your kind of data scientists and your maybe data engineers, machine learning devs, and devs in general are gonna spend quite a bit of their time. Um, yeah, and it turns out that, like, solving this problem, which is the managing all, not just like building the model, which is what everybody thinks of when they think of data science. Like, I'm going to get the model, it's going to have 80% accuracy, and like life's going to be good. But it's all the peripheral stuff around, like, life cycling and making sure that your model isn't drifting in terms of accuracy, or making sure that latency is okay, or that you're using the best model, and that your developers are able to transparently tell what the model's doing, and all the hyper, it goes on forever. That's the onerous part. And that's the part that this really solves, which is cool. And then on the bottom layer, we have machine learning frameworks and infrastructure. So this is where you have your TensorFlow, your MXNet, PyTorch, Keras, scikit-learn, which is where I got my start. So lower level stuff that you would actually use to build algorithms, build new deep neural network architectures, do reinforcement learning, like, which is where a data scientist, or especially in academia, this is where we're going to spend a lot of time. It's kind of deep tech. Cool. All right, so I think it's the last slide up. No, we got a couple more. Sorry, I'll try and keep it interesting. So why should we care about computer vision? I think for me, it's pretty obvious, but basically the market is growing rapidly and massively. Camera resolution and frames per second are just going to keep increasing. I came across the other day, it was a 360-degree camera at 4K at
No way.
120 frames per second, I think it was, or something. It's just like the amount of data coming off of out of the edge is just like crazy. That
We should
said,
jump
like,
for 6G instead of 5G then.
yes, we need to jump a couple of G's, man. Yeah. That said, like, 5G is coming, but I don't think that in my opinion, these bandwidth constraints are not going to move as fast as the data growth is going to move. And while we've come a long way with decreasing the cost of things like training and inference with things like SageMaker Spot and inferential chipsets, elastic inference, multi-model endpoints make inference where around like 90% of the cost typically lives in machine learning cheaper. And we have more inexpensive machine learning inference hardware options like the Jetson, the Raspberry, Coral, et cetera, et cetera. The vision element is going to continue to be a challenge, and it's going to be something that we are going to continue to need to work to make more and more accessible to normal folks, to include consumers, I think. And then, of course, we have new connectivity types. So it used to be that even if you had this edge device, it could do computer vision well. You could deploy it to the field. That's cool. But like, it still needs to talk to someone. Like a tree falling in the forest,
Makes
doesn't
a
really
sound?
matter.
Yeah.
Yes. So like at some point, the edge device needs to communicate with the rest of the world. And it used to be that you could rely on store and forward or satellite, which is expensive and tricky, or maybe a radio. But now things like LoRaWAN and MQTT and Zigbee and some of these other low power, low cost protocols for transmitting information are really becoming ubiquitous, and that creates new options for sending packets of information, smaller packets of information into the cloud with relative ease, which is cool. Sweet. All right, so the goal of the Evergreen project was to take one of those things, a Jetson Nano, unbox it, and then execute a shell script and have it ready to go running custom computer vision models from a off-the-shelf USB camera within 10 minutes, excluding the time where you're just sitting around waiting for SageMaker to do its magic. And I'm happy to say that we've probably got that under 2 minutes.
Wow.
When I first, it's just a couple of
It's
clicks.
faster
Like,
than buying a Raspberry Pi. Wow.
yeah, it's like, yeah. When I've been working on this for at least 9 months now, and I remember when I was like, all right, so we got this Jetson device, like, machine learning on the edge, like this can't be that hard. Like, I got a bunch of images. I want a machine learning model that can differentiate between these two tractors. I have the images. Give me the model. How do I make it go? Make Rocket go now. And it turned out that was not as easy as I would have liked. But I'm happy to say that with the help of some other very smart people, we've gotten that down to just a few clicks, which is cool.
Yeah, good for our customers for sure.
Yep. So for the architects and wannabe architects out there, this is the architecture that we're basically working on. So at the left there, you've got your user. They're interacting with an edge device. That edge device can basically it can do a few things. One is that it can fire a request to API gateway to train a new model. And so basically what that means is you're saying, here are the images that I want you to use to train my new model in these two like folders in S3. I want you to go away, use all those images, do whatever you got to do, and make me a nice classification model based on that. That said, you don't have to actually fire that request from the edge device. Like you can do it from anywhere. The other thing that the edge device does well is it does inference. So, you send that request out. SageMaker says, "All right, cool. See you in a little bit," and then it basically sends you an email and says, "Hey, your model's ready." You then log into the edge device via SSH or Greengrass in the future, and then you pull down the model and start to do inference. So the users basically, I mean, SageMaker does all the training and stuff inside an ECS cluster in the cloud. All that heavy lifting happens in the cloud where they can really benefit from economies of scale. And then on the edge, the user basically just pulls down the model and runs it using the Neo deep learning runtime, and it does inference. Yeah. So yeah, again, like just a teensy bit more detail. So inside the cloud, Evergreen basically runs an ECS cluster with Fargate tasks. So Fargate ephemeral containers that get spun up to do things like split out the frames and downsample and interpolate, and then run the training, then compile that specifically for the Jetson architecture, and then load that compiled model to the cloud, and then send a notification to the user that their cake is ready. Cool. All right, so here we go. This ought to be interesting. So this part involves me wearing, it involves me wearing a webcam on my head. So that if anybody gets motion sickness, now is the time to look away. Right, so first things first, I'm just going to switch over to my device. 1 second. Share screen.
Let's pray for the demo gods to help us now.
Yes. There it is. It's looking good. Allow. Can you see that, Eduardo?
There we go. We have on
Yeah,
the screen.
buddy. Yeah, buddy. All right, cool. So what this is let me see. All right, now's the time. I gotta test out the limits of my cord. All right. It's not looking too bad. Maybe. Yeah. No, this will work. So this is my janky demo rig. So it's built on a fence paling, and it's basically got a Jetson Nano right there, with a Wi-Fi card. With a Wi-Fi card underneath it, which is what those antenna are. So it automatically connects to my Wi-Fi network. Then it's got a little old school Raspberry Pi next to it, which I just kind of use as a device to simulate a device. I sometimes plug a little thermometer and humidity sensor into it so I can stream data into the Jetson. And then I have just a Logitech, USB camera there for my input. And that's connected directly to the Jetson. Okay, cool. So that's really there. Like, this is not sleight of hand. There is really a board that's stuck on my cord right down here with the camera attached to it and the little light on.
No magic, no expensive hardware, just compute.
No sleight of hand here. This is a real demo. This is it. This is really happening. Get my camera started. Okay, cool. So this terminal is me SSH'd into that device. And so what I'm going to do is, let's do it. So inside on the device, I've got a bunch of different stuff here. And so what I want to do is I'm going to just execute a shell script that is going to set up the device. So if you just bought a Jetson Nano and you pull it out of the box, this is what you would do. So you execute this little shell script. It's going to prompt you for your credentials. Make sure that you've got all the dependencies that you need at the right versions and blah, blah, blah. Like, this was actually probably the hardest part of this whole project, was figuring out all of these dependencies and exactly the right combination of things that needed to go onto the device, followed very closely by the the information and parameters that I needed to compile a model that came out of SageMaker appropriately for a Jetson device and then run it, blah, blah, blah. So
So is
this
brand
base,
specific in this case?
sorry?
Is brand specific in this case?
Yeah, so in this case, it's specifically made for the Jetson Nano.
Mhm.
Or any Jetson device though, so like a Jetson Xavier or TXT, any of those Jetson series devices would work. And there are similar parameters for Raspberry Pi and Coral and any other kind of device architecture that you want. So that's coming is an extension to those other device types. Cool.
Sweet.
So now that the device has checked all its dependencies and it's happy, it says, "Hey man, you've got a bunch of different compile jobs here, which are compiled machine learning models specifically for the Jetson. Which one do you want?" And so it recommends that I use the most recent one here, compilation. Well, you can read it. And so I'm like, okay, cool. Yeah, that sounds good. Enter. And so it's like, all right, sweet. I'm going to do a little bit of feedback for you on, this is a dual, so a binary classification, binary image classifier model. I'm just going to download it here. So it's 42.8 megs. Sweet.
Almost
Wait
there.
for
There you go.
it's coming. It's coming. It even gives a little bit of feedback on like so you can see there it's the GPU code, which is the GPU that's supported for the target hardware architecture, the different classes that it's running, the S3 ARNs where the models are located, so a bunch of good stuff there. While it's downloading your business, here it comes. Cool. So now it's unpacking that model, so unzipping and unpacking that model onto the device, which again,
on the edge,
right beside
right?
me, right beside me. It's as edgy as it can get around here. And so now it's spinning up the Neo deep learning runtime on the device so that it can start to do inference. Drum roll. This might take like 2 seconds, so don't let your hands get sore. Yep. So it usually doesn't take long. It should be anytime. Bingo. All right.
Ooh.
So here's where it gets interesting. So I've got my device here. I just moved it into my lap. Yeah, this is all right. I'll try and okay. Okay, that's pretty good. All right. So now I'm just going to take my camera, which is connected to the what have you here, and I'm pointing it. This is where I have to use 2 webcams, and it gets crazy. So I'm pointing it at this little green tractor, right? And so this is class 2. And so if I can line it up correctly, hey,
Class 2, there we go. Yeah, we have a class 2. Fantastic.
So I don't have tons of light in my office, and some of the angles, like I didn't give it that much training data, so some of the angles can be a little bit challenging. Let's try
Class
and turn
2
this
again. There we
sucker.
go. We have another one.
There it is.
Class 2.
So
Perfect. Oh,
yep.
beautiful.
Yeah. So yeah, it does work. That's class 2, and I'll get the other tractor here. Red tractor is class 1. And class 1.
Class 1 constant.
So
there we go.
yeah, different zoom levels. It's happy. I haven't actually gotten to the point of doing the automatic hyperparameter tuning, which I should. There's some other stuff that I want to do with like augmentation, so generating more data, because I basically just let's see. I'll give a quick demo of what I do. So in order to generate the training imagery for this project, one basically takes their cell phone, you turn on the camera, and then you just kind of you do this number right here. There it is.
360 on the yep.
Yep. So you get 360 imagery of the object that you're working on. Split that out. It does take a bit of so the trick is getting as much diversity in terms of the background lighting, shadows, and stuff as you can, so that the model is as generalizable as possible. So that's something that when I get a little bit bored, I grab a little bit more imagery of the old tractors. But it's also something that I think it's the plumbing's all there, and so adding more data and working with different types of models and hyperparameters is something that is relatively straightforward at this point. Yeah, so that was your edge computer vision with custom models.
Beautiful.
Yeah, and I'll
Working
just go
on the edge.
working on the edge. Yeah. Um, so yeah,
So
it's pretty cool.
to train a model like that, how long it usually takes, Stephen?
So that model, let's see, I probably did like 6 little videos. Each video 20 seconds of the 2 objects, and that's just on like different backgrounds and different lighting, different shadows and things. And I do transfer learning from a pre-trained model, which is kind of part of SageMaker when you're using the built-in image classification algorithm. So yeah, so it's pretty easy, really. Like, it's a lot of steps, but all those
Yeah.
steps and that complexity can be automated. So yeah, it's no biggie.
Fantastic. And there's some comments over here. There is any base project on GitHub related to that, or something that people could look at the code source around that?
I'm so glad you asked. Whoever that was, they were not a plant. Um, yes. Well, no. The answer is no. But there will be very soon. So I put out a blog on using recognition custom labels for doing machine learning inference on kiwi fruit types last year. I don't know, something like that. So that was kind of the first installment to get my beak wet. So that was the easy one, like the cloud side one, using an AI service. Like, that's a piece of cake. So I'm a colleague and I are going to be pushing out another blog post that includes code samples and CloudFormation and a bill of materials for getting your device and assembly guide and all that stuff in the next little while. So look out for that, and that should have everything you need to get up and running. Yeah.
Cool. So keep an eye on the links, and yeah, you see something coming.
Yeah, man. So I'm not tracking the time at all. Sorry, Odoro.
No,
Okay.
we're still on time, no worries.
All right. Yeah. So in terms of next steps, one of them was I wanted to make it so that a train compile video processing job could all be orchestrated using ECS running Fargate containers for the pipeline. That is all done. So another one is to integrate so access to imagery, so that if you don't want to, you don't have to supply your own imagery to create a binary classifier, for example. So connecting to something like Coco, so that people can just be like, I want a pineapple versus cat binary classifier, and it's like, okay, here's your pineapple images, here's your cat images, Bob's your uncle. So that'll come. True multi-class support right now, it only supports binary classification of imagery, so I want to do that. Support for non-Jetsons, support for bounding boxes, optionality to run a hyperparameter tuning job as part of the train compile sequence, and then bundling all this stuff out with a blog and that bill of materials and all that enablement stuff, so that anybody out there, even people that are not very technical, can start to experiment with computer vision at the edge. That's kind of the dream.
Fantastic.
Cool.
Damn, dude, that's really cool. Questions. All right. I think first of all, dude, pretty cool demo. It worked. Thank demo gods for that. And from my side, I'm still curious after all of this visualization about the edginess, the range of the edginess, and the computer vision from how it started and how it is today. You mentioned in the beginning a lot of the agri-tech in New Zealand are using computer vision. Do you have anything else around the market, not only on agri-tech, that are using computer vision at the moment?
Yeah, good question. Yeah, I tend to focus on the ag tech stuff, but I also think specifically in New Zealand, we're pretty ahead of the game in terms of health and safety. That's another one. It's like the combination of primary industry, which is kind of inherently maybe a bit risky, with New Zealand's commitment to health and safety, means that things like computer vision for PPE, making sure that people aren't walking around in jandals while they're cutting down trees or whatever, like, is another interesting application. Another one is in healthcare. So interpreting things like radiological outputs, MRIs, like any kind of 2 or 3 dimensional output from a scan or other medical procedure, like a device that's emitting a bunch of data, and then interpreting that in near real time at the edge through machine learning and deep learning inference is another really interesting one. And then of course self-driving, like self-driving is all over the place, and
Everywhere.
it's a perfect fit. And especially, so the last one I would say is that um, uh, yeah. So New Zealand. So LoRaWAN is globally something that's so AWS is extending the coverage and the accessibility of LoRaWAN, which is one of those low power connectivity options or protocols for pushing data from bandwidth constrained environments to the cloud. And the tie-in between edge inference and Evergreen and LoRaWAN for its ability to backhaul to the cloud, I think is a match made in heaven, and that's one that I think is going to really take off, especially in New Zealand in the next few years.
Oh, fantastic. And that means if people want to keep an eye on that, they can connect with you on LinkedIn or something?
Yeah, yep. You can hit me on LinkedIn, or you can send me emails. LinkedIn's probably better, to be honest. And yeah, I'll try to do my best. I'll definitely publish on LinkedIn when we have all those assets ready for people to try, but it shouldn't be too long. Yeah.
Oh, fantastic. Well, anything else that you want to call out before we sign off today, Stephen?
Uh, nope. I'm happy.
Happy it worked.
Yeah. Happy it works. Yeah. No, I'm good.
No, that's fantastic. That was beautiful. All right, then. That's all for today, folks. We will be back in 2 weeks' time. So with another episode of From the Field, keep an eye on the link on LinkedIn and also on our website, as we can see on this slide, fromthefield.nz. You can connect with us on our LinkedIn group and also via Twitter. So feel free to follow us and send you some questions, and we'll do our best to keep everyone involved. So that's it. Thank you, everyone. Have a good night. Thank you,
All right.
Stephen.
No worries.
Bye.
Matewa. Bye.